This is a quick video to just discuss interpreting confidence intervals. Here I can use a few pictures and that might clear things up a little bit. So a 95% confidence interval, just so we're clear, is the range of values that we expect contains whatever it is we're trying to estimate. Now, technically speaking, a 95% confidence interval is a range of values that 95% of the time will contain the true population parameter. In other words, the thing we're trying to estimate, right? That would be this here. So in this case, the true value of the population is 0. That's the dotted line that I've drawn over here. And then each of these dots represents the mean of a sample I drew from that population. And I went ahead and did this 100 times. The bars here, the error bars, represent the 95% confidence interval. Now you'll notice 1, 2, 3, 4, 5, or 5% of my samples are colored red, and that's because their 95% confidence interval doesn't include 0, the true thing, right? That's the actual value. But 95% of my confidence intervals did have 0 in them, so they weren't wrong. Sure, the average is sometimes a positive number, sometimes a negative number, right? Sometimes it's quite different from 0, like this one right here. But still, if we draw that confidence interval, we do include 0, so it's not wrong. Now, the mean is, of course, almost always wrong. But the confidence interval is only wrong 5% of the time. All right, we got our videos to show us how to generate confidence intervals. How do we interpret them? And so here again, the dot is the mean, and then the error bars would be the 95% confidence interval. So let's say we generate a 95% confidence interval showing us the difference between two groups. So let's imagine this confidence interval here going from, I don't know, we'll just throw in some values, negative 0.2 to, I don't know, positive 0.8 or something along those lines. Okay, so I've got this 0 line here. I'll make it red. And what you'll notice is that, well, 0 is in my confidence interval. And so I have to conclude no difference between the two groups because 0 is in my confidence interval. What if 0 isn't in my confidence interval? Hey, like up here, let's say I go from something like a, I don't know, 0.3 to a 1.2. Well, 0 isn't in there, and what is in there is this really important value. So if you're dealing with health sciences, this is the minimal clinically important difference, or the noticeable difference. Now, statistics can pick out really small differences, but people need larger differences in order to notice it. So we have to ask ourselves, what is the noticeable difference? And in this hypothetical example, it's 1, positive 1 favoring one group, negative 1 favoring the other group. Now notice 1 is in my confidence interval, so I can't rule it out. That might be the true value, 1.1 might be, 1.2 might be, but of course values smaller than 1 might be. So this is a possibly, or you could lump both of these options together, potentially noticeable or meaningful difference. Why? Because I could have differences larger than the smallest difference I care about. Okay, what if I have a confidence interval now over here, and let's say this is, I don't know, 0.9 going all the way up to 1.6 or something like that. Well, most of it's above 1. Certainly we don't have any reason to believe 0 could be true, so it's statistically significant. Is it meaningful? Probably, but hey, maybe not. 0.9 could be true. Anywhere in this confidence interval is equally true. I don't say that I clearly have a meaningful difference unless I have something like this. Let's say my confidence interval goes from 1.5 to, I don't know, 2.5. No reason to believe 0. right? I'm looking for 0 to say, is it statistically significant? Right? If I don't have 0, then it is indeed statistically significant. No 0 up here. Right? From 1.5 to 2.5. Then I look for whatever value matters. In this case, let's call it 1. That's my value that matters. Now, I am not telling you that 1 is always meaningful. I'm just saying it is in this hypothetical example. You have to figure that out on your own. This is absolutely a judgment call. If you're doing some kind of clinical trial looking at health, you want to go look up the MCID for whatever the outcome is. If it's pain on an 11-point visual analog scale, you'll probably pick somewhere around 2, maybe 1.1 at the lowest. You want to go look it up for your given condition and your given outcome. What is a meaningful difference? If you're doing educational research, it's a judgment call. 5 is pretty good. It's half a letter grade. It's totally up to you to decide what is meaningful. Don't pick anything wacky, though, because reviewers will not be on board with you. You have to have a reason to justify what's meaningful. So in this hypothetical example, it's 1. Do I have any reason to believe that 1 or less could be a possible true value in this confidence interval? No. The lowest I'll accept is 1.5, so this is clearly meaningful. What if I have a case like this down here, though, where I have to believe that 0 could be true, but also something greater than 1 could be true? Let's say in this case I'm going from like negative 0.6 to, 1.1. Well, 0 is in the confidence interval, so I have to say that there is no difference. But I also have 1 and 1.1 over here, so there's no difference, but it's meaningful. That makes no sense. What this tells me is that my confidence intervals are too wide, and that means I'm dealing with an underpowered study. I need a bigger sample size to narrow these confidence intervals so I can say something that actually makes sense. If I tell you there is no difference, but you'll notice it, you're going to think I'm crazy. But I have to say that because the sample size was too small here. Okay, that's a quick little video to talk about interpretation of confidence intervals with a couple visual examples. If anything on here is unclear, make sure you use the questions box and let me know so I can further address anything that doesn't make absolute sense. See you later.